Uh, Good morning, Professor Pesh.
Good morning.
How are you?
Oh, not too bad.
Okay. The weather is better now.
It's improving. It's improving,
Ah,
yes. It is better than it was. The temperature today is about 6 degrees Celsius. So for us, 6 degrees is quite nice.
I suppose.
Yeah.
Not here in Mexico. Six degrees are cold here.
Yes.
Yeah. Mhm.
But this year you have some cold weather, I think, or for Mexico is a little
Yes.
cold.
Yes, but today is not so bad. I don't know how is the temperature today, but there is sun shining
Yes.
soon, and it is okay. It's okay.
Warm enough then.
More, yes, yes, yes.
Yes.
Oh, sorry for the line. Because now is 10 and 10 minutes. Yes, okay, sorry. But Professor Garrett is not yet connected.
I don't see him yet. I just was waiting. I know it's been 3 weeks since we met, and I haven't had any communication. But I think he understood that we were meeting again in 3 weeks.
Yeah. Mhm.
I'm not sure. Perhaps he has some problem, or
Okay.
I don't know.
I was trying to go um, far in this idea of working with the graph and Clifford algebra, and I think that I am finding some interesting things, but I need to organize this better because there are many um, important concepts that are coming in this subject. Then I think that I need to be more careful in the presentation of all of this. Mhm.
So you were continuing with the subject of graphs like this.
Yes, yes,
So we have a hierarchy of graph structures.
yes, but I think that for this subject of complete graph and Clifford algebra, it is enough with the concept of multigraph. I do not need multigraph or multigraph, for example. Because the Clifford algebra and complete graph, I think that are related in a hierarchical way. And then it is enough with the concept of multigraph.
So the concept of multigraph, as I'm familiar, is to consider edges which join more than one node, more than two nodes, I should say.
Yes. Yes.
So, an edge is something more complicated than an arrow. It's not just simply a source and a target, but it must be, well, I'm not sure how you formalize multigraph in the same way, but one would have to, I suppose, consider I'm not sure. You need to consider sets of a set of sources, perhaps, and a set of targets.
Yes, this is the idea, to use sets of sources and sets of targets, and then a couple of source and targets are a morphism. Then, in fact, we can use different kind of morphisms in this builded graph.
Mm-hmm. So we still have the notion of morphism in the sense that there is still a notion of a source and a notion of a target.
Yes.
I see.
Yes. I have not a graphic with multi-graphic here, but maybe I can write something. Maybe.
Sure. Yeah.
Okay. A moment, please. Okay, I'm going to share here. First, I think that an important step in this is the idea of going from a direct graph with the vertex and no, sorry. No, a direct graph with the vertex and edges. And then we can define the graph in this way. This is the traditional definition of no. But
Yes.
the idea is here. First, B is a zero cell. Then B is a graphic that can be called GO, for example. And the set of edges, for example, this, are one cells. And in fact, they are one graph. Then we can find relations between
Just
GO.
one subtle
Yes.
point is that a set of edges alone doesn't define a graph per se, right? You need also these functions S and T in addition to the set. Can you, if you don't say how the edges are connected, then
Yes.
I'm not sure.
But here, in fact, maybe I can draw in this way, because I have not vertex here. I have only edges. And maybe I can have direct edges or not. For example, I can have this kind and some in this way. Then this is an E1, E2, etc. And this is a kind of one cell that is I see your point. Okay, here.
It's this without vertices, then we cannot define S and T.
Not yet.
Right?
Not yet. Yes, yes, yes. And here we have this S and T with G1.
Yes.
Yes. And here we can go to higher order. And now, for example, G1 can take the role of vertex, and then we can define with G2. G2 are relations between something like this with so, are a relation between those. This is a G1 and G1 prime. And then if I establish one morphemes between these two, then I have here a two graph, two graph that are this relation between GO, G1, and G2. And
but do you have any constraint on the functions S and T from G2? Are they constrained in some way to be compatible with the functions S and T from G1 to G0, like so that the like it would be like to connect an edge which is not connected by a vertex, right? So like a compatibility between G0 and G2.
And if I understand, maybe I can make another picture. For example, I have this graph. Only this. And in this, I am going to put some labels here. And then, yeah, and I have here another one. Okay, then I'm going to establish one relation between vertex, maybe A and A2, and here B1, B2. Maybe I have more vertex here, but those are not related. And I need one more that is the relation between and D1, 2. And then I need this. Then I need one relation here between maybe here alpha. This is the morphism that I use for the relation between vertex, and this is the morphism that I use for the relation between edges. Then A are defined between what's yes, E 1, 2 to D 1, 2. In fact, this is a natural transformation.
Yes, I think that was
then
that if we were to write that A was mapping to D23, then this is not natural, right? This is, if we were to write E12 to D13, but alpha is mapping A2 to B2 and A1 to B1.
Yes.
Well, is this acceptable?
In fact, I wanted to add one more vertex that are not included in the transformation.
Mm-hmm. But
Then,
in your previous diagram,
yes,
you maybe can you return to your previous diagram? Yeah. Okay. Yes. So here, when you write G0, G1, G2, the mapping from G2 to G1 is this mapping between two edges. The G1 are edges, right? G2 is something more higher order, but G1 is an edge. But so when you think of the two graph, that you think of all of this information together, perhaps like G2, G1, and G0, and then these four mappings here. You have the
if I understand, I'm going to erase here in the way I have more space here. Okay, and okay, I have here GO. No?
yes.
And now I need, you say, I need this vertex and edges, for example. For G1.
Yes.
And in the next, I need an okay, I need this, and maybe those, something like this. And this included relation between vertex maybe it is not in the other, and relation between maybe another color, no? Between edges, for example, no? and this. These two is the same that the double arrow that I have here. And then I have now here G2.
Yes. it's okay, I think, except that I am I don't see in your diagram G0, G1, G2 above. I don't see that it includes this possibility of defining the G2 morphism as a pair of as a mapping between edges and being also a mapping between vertices.
Vertices. Okay. But because I think that the source and target, maybe another one more, source and target are here. This double arrow is the definition between source and target here, between the two G1s.
But also G0. So
yes, but G0 was mapping to G1 taking source and targets. Then here I define this, for example, like a target, and this like source between these two vertex. And at the same way, I define here this like source and this like target. I need to add some label here in the way that this is the first arrow, and this is the second arrow. No? Okay, and here I have this, but in the next, I don't know if it's better to erase and draw again. And taking this process here, I can, okay, I can, this is the first one. And okay. I am going to add this here. Then I need to define source and target for vertex and for and for arrows. Then this is one, and this is maybe here and here, for example. I call it this, for example, alpha. And I need maybe this here, in the way that this is takes sense. We need here, and this is here, and the last have not correspondence with here. Okay. Then I call it this A. And but now in this graphics, this is this is the G2.
But this alpha and A together are just a single morphism, right?
Yes, yes. But alpha are morphisms between vertex, and A are morphisms between edges.
But I expect to see here source and target morphisms.
Okay. Okay. And then source and target. Maybe I'm going to get another because it is easy to lost the picture.
Okay.
Okay, I have here. Maybe I'm going to put names. And now I put the same name and I put the arrows. Okay, then yes. Source and target are here. This is source, and this is a target, and this is a source, and this is attached target. And like in the past, I put this S1, S2, T2. No? For E1 and E2. Okay. Okay, now I am going to draw again the E1 here are the vertex A1, A2, A3, and the edges. Okay, this is my starting point. And now I want to build another but I am going to no. Okay. I am going to call this in a different order. E3, E1, E2, and I'm going to relate E1 now with E3 and E1 with E2. Okay, and now the names it's not good place. And now I'm going to put here E1 prime and E2 prime. Okay, then I am going to to show here source and targets. Then here this permutation of E2 and E3 is now related in this way. E1 this is a source and this is target. Source and target now in this new graph. Maybe I'm going to put a S1 prime, T1 prime. Okay. And this is again source here for is2 prime and target is Okay. This is T2 prime. This is the relation between the between the vertex, and now relation between edges. Then E1 okay. E1 is the source and I need to draw, but out of here because this is source and because E1 prime is 3. No. Because this is moved to here and this is moved to here. But we need the source and target here.
Yes. I think one difficulty is that in the diagram at the top, the upper diagram, you have something that is G0 and something that is G1.
Yes.
On the lower diagram, you have something that is G1, but I don't know what is G2.
Oh, okay.
G2 must be something else, something. And I'm not sure how to make a picture of this something else.
Yes. Yes.
But if the E's without the prime, if these are the edges of G1, right, then what we draw as edges of G2 must be something different, something. The edges of G2 would be mapping one edge of G1 as source and another edge of G1 as target.
Yes.
Right. So
maybe in this way that you are saying, for example, source and target. And this implies that we have built this relation.
But see, the source and the target in the diagram above are indicated by the edge E1, because the edge E1 has a beginning and it has an end, right? And so it has a source vertex and a target vertex. But in G2, you would have a source edge and a target edge.
Because if sorry,
maybe it's I think you need for this G1, which is on the right side of the bottom picture, you need that the E1 is a vertex, is a vertex-like structure.
Okay, is
and E2 is another vertex-like structure.
Okay.
And then between those two vertex structures, then you would draw an arrow. And this arrow between E1 and E2 would then define E1 as the source and E2 as the target in some G2 structure, right? In some.
Okay.
It's because in the diagram at the top, you have implicitly you have these labels A1. They're used in both. They occur again. So you need the E1 and E2 to occur again on the in G2, but
yes.
between E1 and E2, you then have something new, something like F1 or something,
Yeah.
right?
I think I can understand your point, because if for example, here there is not still relation between the edges. There are no relation between edges. Then I need to establish these relations. That means what is the starting point and what is the end point. And then if I build now here, this is a starting and this is the end, then I am saying that this is source and this is target. Because I am putting the arrow in this way.
Do you have the option? I like to to perhaps draw, but do you have the option to enable me to make annotation?
I don't know if I can. I'm going to here to Zoom and
under share, I think you have option to
or maybe in the Blackboard here in Zoom directly, but maybe I stop.
Oh, I see. Because yes, you make annotation on your an app on your screen. Yes, as opposed to
Yes.
a Zoom, not a Zoom
Yeah.
whiteboard. Yes, yeah, I see.
Then okay, here and okay, here is quite vast. Maybe now you can make it annotation.
Yes. Yes, I think so. Okay. So I like to have let's see, draw. Okay. I like to write first of all. This is G1. Oh,
Okay.
this is not so good. Not very good. Let me correct the size.
Okay.
How to do that? How do I make this one? I think so. Still, is why is so big?
Maybe.
Okay, I am not sure. Maybe it's okay. Large pictures are all right. So first we will have. Okay, please draw. So I would like to have G1, and it will be as you drew it. There is node, and there is edge. It's something like this. And now
Okay.
I have G2, and so G2 will have how to write. Let's see. So we have this A1, A2, and A3, and we have E1 and E2. It's okay. So, but now we have here point, but we call this point E1, and we have another point, another vertex, but we call it E2. And now we draw an edge, and we call this something like F1. And what this means is that this edge E1 is source, and this edge E2 is target.
Yes.
So so we draw with, let's choose another color. So we have this mapping that says that this what to do maybe this well, we must establish that this is 2 and this is 1 and this is this is source and target.
Okay.
Is it?
It's nice. It's nice. Okay. Okay.
So you drew, originally you said that you have this like this, right? Source and target, right? And you had before we had this other other color that was here G0, right? And you have source and target, right? But this source and target is this source and target is given by these edges, right? But this source and target is given by this edge.
Yes. Okay.
So we have here what we treat as treat it like a vertex, but it is the label of an edge, right? Yeah. So this E2 is it is drawn like a point, but it actually is the edge in G1, which so we must, in order to go one level higher, we must treat edges like vertices, and then we have some new kind of object, a G2 morphism, which is now we draw it like an edge, right? But this morphism F is more complicated than this morphism E2, right?
Yeah. Okay. Yes, I understand. I like to draw here to one side of your picture.
Sure.
For example, how we can see E1, and E1 is, for example, this is E1, but is together with A1 and A2. And E2 is I can draw in this way. A2, A3, and this is E2.
Yes.
Then this relation here that was, I don't remember what letter, maybe is F?
F, yes, here? F. This is the label of a
of the
edge of G2 in G2.
Okay. Mm-hmm. And this is this F is here. Relating the edges and the vertex.
Uh-huh.
Mm-hmm. Okay. This is one. Okay. And then but I think that we need one morphemes in the original G1 graph. Then maybe I can erase something here because I need the complete scheme of all the okay because this object here is the original G1. Then I need this E2 and A3. And then I am going to establish one transformation, one morphism of this graph. And because I said that maybe at the end that is here, I have a different, for example, only that. And then I need to establish some relation that are indicating source and targets here. And then I don't know if I can use another color. For example, okay, at the end, this is F1. Yes, this is F1, but how is related with the relations between a vertex in H1 graph? Because here I have sorry, maybe you are going to say something.
I would say that I prefer maybe to how to say it. I wish I don't know how to use this tool quite. Let's see what I can do here. No. Okay, that's better. If I okay, what if you don't mind? Maybe I can erase some small part of what you drew.
Yes, yes, you can.
Yeah. So I like. Let's see, is this working? Can it erase? It does not want to erase. That's interesting. Maybe I cannot. Okay, let's I can do this maybe. Can I move this? What do I move? One moment. I like to have just in the first source. I would have E1, E2, but no A1 and A2 and A3, but only E1. No A no. So I have here. Let's see. So I remove this.
Okay. I can remove this maybe. Okay, and this.
And yes.
Yes.
But this is yes, this is correct now. And now we have again below we have A1, A2, A3, but then we have no E1, but we have E2 instead.
Okay.
Right?
Here is E2. Okay. This is E2 and E3. And this is A2. That's right? Yes, it's okay, but you should also have E1 or A1. You should also have A1, but it's not. Here, A1, okay?
Yes. Yes, exactly.
Maybe here A3?
And there A3, yes.
Okay.
And this says that the mapping between the vertices in G0 is identity. Like it's
okay.
Because we write that we use the same labels A1, A2, A3 in both places, so it's like identity.
Okay.
But we use this source A1 and target E1, right? E1 and E2, right? So it's so F1 maps E1 into E2, but it also keeps the vertices the same as A1 becomes A1 and A2 becomes A2, etc. But it's possible, I think, that we could have a different mapping between vertices, but this different mapping must be compatible, right? So for example, let's see, what could we do? We could maybe we could have let's see, not so simple to see what else we could do, right? Because we want always to respect the F1. F1 has to only map one edge into one edge, right? So it's E1 into E2. But for example, if we had, suppose we had one more, maybe I can draw this. So we have, say, one more vertex. I will change my color again. Okay, color back to this color, and size is bigger, say. And, so now we have this, say, and we have, we call it A4. And so now here, try to do this. So now we would have, say, here the A4, and here whatever A4, right? But we might map this one. So which one is? Let me think. We want. Here we have two nodes, two vertices that are not connected. I want to exchange, right? But I can exchange freely. Maybe I'm not clear. So
you need more space for draw, or not? You like to draw in in the same picture?
I like to draw in the same picture. Because see,
maybe I think so where is the problem? Maybe if I have here some kind of vertex, and after we have here again the same vertex, and now I am going to draw some arrows, edges. This exercise is made defining source and target. For example, this this is my graph, and now I'm going to draw the same here. And I like to No, this one not direct. And now I want to relate, for example, this in the same way, source and target.
Mm-hmm. Between these edges.
Between these edges, yes.
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 But you can put another double arrow. You can put also,
for example, here.
For example, yes.
Yes.
So now I like this picture as this is a good picture of G2.
Okay. Okay.
Right? Because this says that we have, except it's maybe not complete. Let's see, can it be? No, it's okay. Yeah, it's okay. So these things with double arrows are the edges of G2.
Yes.
And
yes.
the single arrows are the edges of G1.
Yes.
And the vertices remain vertices, right?
Yes.
G0, right? But just as we went from G0 to G1, we can draw in these connections between the vertices. When we go from G1 to G2, we make connection between edges. Now we could make G3 if we like, but then we would be making a triple arrow, say, between these two double arrows, right? Yes, like this, right? This is okay. So this is the picture that you drew of G1 with S and T, G2 with S and T into G1, etc., and indefinitely higher. But we have this.
Yes, and now I understand your comment in the way that there we need some consistencies between the vertex, the possible arrows, and the double arrows, and so that this cannot be, for example, different numbers of vertex, no? In this graphics, because if I add more vertex in the second draw, then I am modifying the graphics. Okay.
But we are free to add as many double arrows as we wish, right? Or perhaps no double arrows, right? But if we do not have any double arrows, then we cannot draw a triple arrow.
Right? Okay.
Right. And if we have only a single double arrow, then the only triple arrow we can draw is a loop.
Right? A loop, okay.
A loop triple, a triple,
Yes. Okay.
And in the diagram as you drew it now, this is clear that this compatibility is included, right? That because we are our mappings are between only the objects of that kind. We don't have one mapping for.
Yes. I think that
Yes,
they
it's okay. This last diagram is best.
is best. I think that we can get a better view of this. Sorry, I'm going to share my screen.
Mhm.
And now I think we can use these pictures, but I need a new one, and then now I am going to draw the vertex. Okay. And in one upper level, I have the arrows.
You are not sharing it.
Oh, sorry.
It's okay.
Something was wrong here. Okay. Now
Yes,
I and maybe here and one more here. Okay. And now I am going an upper level here, and then, for example, here, maybe here, and only that.
okay.
And now I'm going to upper level, and maybe here.
Yes.
And then I can rebuild this. And here I have again G1,
Yes.
G2, and G3.
Yes.
Okay.
Yes,
Okay.
I think it's good.
No, this is good. Okay.
But you said you wish to talk about the multigraph. But
Yes.
each one of these graphs, G1, G2, are and even G3 are directed graphs, right? They always have source and they have target, and always it is a single source and a single target. But a multigraph, I think it would would have edges which connect more than two. More, they have more than source and target. So they have, like source 1 and source 2 and target 2 and target 3, or maybe I don't understand what is multigraph.
Because I have using this, I have here. Sorry, I need to change. I have here GO.
Yes.
This is GO. And here I have G1.
Yes.
I am going to G1, and this was making in this way.
Yes.
And now I have here G2.
Yeah.
Making in this way.
Yes.
And now I have
yes, it would be G3.
G3.
Yeah.
Source and target. And this is a multigraph. This is a.
I mean the entire structure you call multigraph.
Yes, yes. Yeah. This is a multigraph.
Or it maybe terminology would be something like N-graph, or
yes, it's a N graph. Because in fact, multigraph is used in theory of graphics in different ways.
Yes, exactly. Yes.
Yes. But here, maybe we can go far, and maybe we can give names. And the next, this is A23. I'm going to use the convention that the vertex give the name.
This could be complicated.
And E71. And now
Now this name is complicated,
Here
right? This is maybe
is complicated.
F2358, right?
E23 are one arrow.
Yeah, so I prefer maybe that you label this edges edge 1, edge 2, edge 3, something like. And then this becomes labeled like F F1, etc.
Yes, only that I was trying to define one matrix for the vertex and then one matrix for the arrows, and after a matrix for the double arrow.
Uh-huh.
Then if I use the matrix for the for the arrows, this says that I have here with I have A1 related with A7, then 1 with 7 is 1, and I need one more. Okay. Yes, and this, and after in the with this A2 and 3, then 2 and 3. This is 1, and the other are 0. And but I have with A2 and 6. Here. And at the I have 1, 2, 3, and one more. A5.
Yeah.
And 5 with 8, and here 1. And
with each
row are 0.
So the rows and columns are both labeled by their vertices.
But the vertices, yes,
yeah.
Yes. Because the Professor Garrett likes to use the adjacent. This is the adjacent matrix. And then, well, I'm going to put a big 0 here. And this is the adjacent matrix for this. But if I go to one upper level, I need a more complex structures that are related.
But if you, yes, you go now to this structure. Now here, if you have a single matrix, then it has only 2 rows. No, let's see.
Okay, if
no, it has. I'm sorry. It has 1, 2, 3, 4 rows and 4 columns.
Yes.
Right. So you have a 4 by 4 matrix.
Okay.
But again, you have zeros and ones. But the zeros and ones are the 2 edges, right?
I need to rename, for example, E1, E2, E3, E4. And then
yes, I prefer,
now
yes.
the and then I am relating E1 with E3. Then here's 0, 0. And
Yes,
this
correct.
is 0. And I have one relation between E4 with E2. Here is 1, 0, and those are 0. Okay.
Yes, correct.
Okay.
Yeah, I think it's all right. But in this adjacency matrix, we do not say anything explicitly about the original G0.
Yes, yes, it is the problem. Because for saying something about the original G0, I need to establish one relation between the maybe the arrows in the first matrix, because the first one, I need to establish one that is, this is 2, 3, 2, 3, and 5, 8, 5, 8. And this corresponds to this one. And the other one is the 7, 1, 2, 3, 4. 3, 4, 7, 1. Are maybe another. This is with this.
But when you draw as a row, you refer to the source. Right? When you draw as a column,
yes,
you refer to the target.
Okay. Okay.
So when there is a non-zero in the G1 matrix, there is one row and one column in the G2 matrix. So we have four ones in the G1 adjacency matrix. So in the G2 adjacency matrix, we have 4 rows and 4 columns. We have a row and a column for each time there is a 1 in the matrix above. Maybe that I wish I could draw.
Oh.
Now I want to draw again. But I like to put, you see where you have here at 2 and 3. 2, 3 you have a 1.
2, 3, I have a 1 in the, and you are speaking in the first matrix.
In the first matrix, right?
Yes.
So we should have a mapping between this one goes to the row and the column in below, right?
Row and okay. Mm-hmm. This one is this.
Yeah, 2, 3. Yes. So you call
the graphic
1, right? So that single cell in the matrix at the top goes to a row and column below. The first row and first column.
Okay, first row and first column. I need you think, for example, write in this way. Mm-hmm. To move an upper level here. Huh? I don't know if I understand.
No, not exact. Let me try. How can I do this?
It's a problem because I move again the.
Is there a way you can choose to allow me to control your drawing? You know, like a remote control or something is called.
Not how can I?
I don't know.
I can do that.
You have some option under sharing, maybe that says allow remote.
Okay, maybe here applications. Okay, here applications. No, it is not.
No, I don't think so. When you choose to share,
okay,
maybe there is an option somewhere.
I need to stop sharing and start again sharing.
Yes.
But here is a screen only, but screen broadcast only. I have the option of move the microphone for transmitting screen broadcast, start broadcast.
I'm not so familiar because you have iPad, I guess.
Yes.
iPad is a little different than the Linux desktop, but. In my Linux desktop, I think it says advanced sharing. Oh, no, that's not it.
But again, maybe I can put the Blackboard, but only needed to.
We can draw again. Or perhaps you can can you insert your graphic into the blackboard?
Okay.
Maybe
Okay.
this is possible.
I think that it is. I'm going to take a picture of this with all the structure.
Yes, it's good.
Okay, and no, okay. By but I can save.
There is no
the option of include
no insert.
not in picture. No, no.
Not so that's good.
No, it's good.
No option to insert. Okay. Well, anyway, let me draw. I
Okay.
will. I will try to reproduce. You have adjacency matrix from G1, and it is you have most is 0, right? But you have here maybe 0 and 0 and 1 and 0 and etc. Right? And maybe you have here 1. These are zeros, right? And etc. And so, but here this is labeled by A1.
Yes.
And this is labeled by also A1. So I think we wanted to have this one A2 and A3. If we change this, it's better to use this. A3, A4, and I like to have here more zeros. And I have like A2 and A3, etc. And but important is that we have this this cell. Now, if I go back to now, I like to write G2 adjacency matrix
Okay.
And this adjacency matrix has only 4 rows and 4 columns.
Okay.
Etc. I don't remember what our G2 arrow was, but the point I tried to make was that I like now to relate this cell with this row and also with this column.
Okay. No. Okay.
So now I have also say I like to make a little more. I have say this is source and this is target.
Okay.
So here's this is target.
Okay.
Target, right? This is source and this is target. So now this row says there is an edge between A3 to A2.
Okay.
But if I write another edge, say from, let us put, say, A4. So we put, say, from A4, we connect to A3.
Okay.
Right? Now, now we have another. Now we have another edge. So now this edge becomes this row, or this column in this row.
Okay.
So now, if etc. So for each cell that we have in G1, we have a row and a column in G2.
Okay.
And now if we wish to say that this edge is connected to this row, but in G2, then we just have, of course, this, oops, and we go back to
Okay.
this one. And we would continue if we write G3, we would have now only single row and single column.
Okay. Okay.
Or maybe we would do, maybe also have another, now we would have two, right? Like we continue this structure like this. Now, of course, we continue to have the possibility to put even a loop. We could have a loop, of course.
Okay.
And maybe this one, but so. But always, if we have to. If I wrote 4 here, right, then I will have 4 different possibilities of. So here I only map like the first two, but this, but it's okay to have at each level, right? This adjacency matrix. But it doesn't, as you said, it doesn't include the information from below.
Okay, I think that this is maybe similar that with the idea of build one tree for the n-graph. Huh? Because I don't know if I can. Maybe I'm going to build again here.
Yes.
The graphics and maybe here. Another one.
Sure.
And maybe here. And finally, okay, here. Okay, and I need some names here in E1, E2. Here is E4, no, E4, E5, and E6. And now I am going to start from the first level. Then the first level, that is the 3 arrow, are connecting these 2 arrows. In the second level, and the first one are connecting 2 arrows, 2 single arrows, and these 2 single arrows, and I have here in this way, and finally these arrows are A1, A2, no, A1, A2, excuse me. Oh, yeah, not enough space here. I need to. Okay. Here, A1, A2, and here are A3, A5. A1, yes, A1, A2, and it is connecting. No, I need one more level here. Because this is a single arrow, and now I need the vertex. Now I went A2, and this is connected with A6, A4. A4, and this same similar is here. This is connecting A4. Yes, A2, A4. Because there is one error here. This is A6. That's right. A6 and A4. Okay, it's right. And here it is A4, A2. A4, A2, and here is A4, A2, 3 and 5. A3, I5. This is the idea. Then a multigraph can be pictured in this way. At the end, I not need this double or triple arrow, but I only need the levels. And this is the same that the multigraph, that is n graph.
This is a binary tree.
Yes, a binary tree.
So at the lowest level, we have G0 is just the lowest, the leaves, and the next level is G1. So
yes, G0, G1, G1, G2, and G3.
how do we draw if we have a loop? Like if we have, suppose we add in one more arrow.
If we have one more
such an arrow.
I don't understand your point.
Let
because
me use a different color. I like to have.
Okay.
Say this. Here is a possible arrow, right? It goes from A1 back to A1.
Back to A1. Okay.
So A1 is both source and target.
Source and target. Okay, but source and target, but is in G1. This is in G1. Then
yes. So how do we draw? in the binary tree, how do we say we have such?
Because this is one.
In the adjacency matrix, it means we have a diagonal. In the diagonal,
okay.
we have a 1, right?
Okay. I think that we need to add here A1.
Again.
Again, yes. Again. Yes. Yes. But in the idea of using this, in the way that we have a category, we need an identity. Then I think that we not need to repeat this, because I need to repeat in all the vertex, because in that category it is necessary that all the vertex has a loop.
But we have the same kind of problem. For example, if we have also this arrow, suppose we have this arrow, then we have one edge that goes from A6 to A5, and the other is from A5 to A6. So how do we?
The idea is here. I don't know if I can add one more page in the Blackboard. Maybe we have the 2 page here. Okay. But the idea is, if I have a complete graph, I prefer this color. If I have a complete graph, and maybe only 3 vertex, and then this. A1, A2, A3. Then I'm going to start with A1. Then A1 is I'm going to add paths here. Then this is 1, and then I am going first to write this, and sorry. I am going to start with A1 and after going to A2, then I have with this and I have A1 to A3. And I have A2 with A3. I am making only the path starting from A1 and going in the same sense, in the same sense. And now I have another one that are the inverse paths because here we have okay like paths I can go from A2 to A1. Okay, I'm going to add here A2 to A1 and I have another one here that are A1, A2, A3, and I have here A3 to A2. I have A3 to A1. Okay. Then we have this we have two trees here. The first one is going from A1 and then go to A2 and then go to A3, A1 to A3. Start from A1 and go to A2 and to A3. But starting from A2, we can go to A3. Then this can be pictured in this way. And then we have here these levels in the path. Then here is the first level, here is the second level, and here is the third level. Each time that we go in this, we only add one more level. Okay, this is A2. But now we have here, we have A3. and here we have A2. This is the same. And here we have A1. This is the second tree. And then we can build this in this form. For example, going from here to here, or going from here to here. And we can go from here to here, or going from here to here. And I have all these cycles that we can build in this graph in this way. Then when I go in this, in the upper level, I am building an graph with a tree, and when I go to the lower level, I am inverting the operations, and then we have in the upper level we have coproduct, and in the lower level we have product. Then this is the idea with the complete graph. I can build one more complex graph with 4 nodes, and then I have not a binary tree, but I have a ternary tree, and so. But the structure is the same. It is the same. Then I think that the purpose of relate this with some algebra, we can think that the first level is the vector space, and this lower level is the covector space. And then we have the duality here in this picture. And then this is the idea for using the n-graphs for analyzing the complete graph.
Yes, this is interesting, I think.
But I need to organize better these ideas here.
Yeah. Maybe next time it would be good. If I will communicate with Garrett Sobchak and be clear on when we meet again, and maybe it's possible you can begin with this diagram you just drew, this product and co-product. I think is interesting concept. They're different, like it relates perhaps the categorical duality to the linear algebra duality.
Yes.
Maybe this is good. Yeah. Okay, I think it's time I must go on to my next job, my work this afternoon. maybe. Well, I will send to you an email when I communicate with Garrett Subchik, and we
Okay.
can perhaps agree on either next week if it's possible for you, or 2 weeks or 3 weeks.
And yes, in fact, in Wednesday I have no problems. I have reserved for
Uh-huh.
the seminar. Then okay.
All right. So I will send an email to you and also to Garrett Subchik, and we'll confirm on the the time of the next meeting.
Okay. Okay. Thank you.
Okay. Well,
Okay.
thank you, Jesus. It was interesting. I remember reading this paper that you wrote with Oshevich on n graphs and or graphs of graphs, and I like to review some of these notes. Uh, I I think for me, I would be interested sometime to have a copy of this book that was published. I think it's Amazon book that
Ah,
has several graphs.
yes. I don't know if I have a copy of that book because this was published with another student in,
Yes. Oh,
in
yes.
in the faculty. But I have the two papers that I published with Professor Osiewicz. Then
Mhm.
I can send to you a copy of them.
Yes. Okay, that would be very useful.
Okay.
Okay. Well, thank you, and I hope you have warmer weather. That things are good. Perhaps for me, I'm looking forward to spring. Like at it, right now, it's warmer than usual, but I expect the temperature to be cold again before it becomes nice. So
Okay.
I
Yes.
don't know. Next time we will see what we have.
Okay. Thanks a lot, and see you. And
Bye for now.
bye.